It's Brendan.
Oh, hi, Brendan. Somebody started the broadcast, so I guess we're starting.
Yes, I'm afraid I hit that button.
Okay, so can everybody see the screen, which shows three beautiful pictures, one of Brendan, one of Bibiana, and one of Aaron?
I can.
Yes.
Okay.
I can as well.
Good. So, Brendan, I'm going to give it to you in a minute. My name is Janneke Venderzee. I am the General Manager of ITS Canada, and I thank you all for joining. I'm handing this over now to Brendan Hemley, who is the Chair of ITS Canada's APTS Technical Committee. Brendan.
Thank you, Janneke. So my name is Brendan Hemley. Many of you may know me. I'm an independent consultant and worked previously for another association, the Canadian Urban Transit Association. Long-standing interest in transit ITS matters, and become the chair of the APTS, which is the Advanced Public Transit Systems Committee of ITS Canada. And as such, continuing the trend of my predecessor, Rajiv Roy, to have series of webinars and so forth. At the very end, if anybody's sort of interested in becoming getting on our distribution list, please send me an email. It's at the end of the session. This webinar is on new horizons in standardized traveler information and for integrated mobility. I've known both Bibiana and Aaron for many years, and they are among the top experts in this field. And I thought there's some very interesting developments going on, and so I thought it would be very worthwhile to have them both talk about recent projects that they're involved in. And so we'll start off with Bibiana and then Aaron, and then have some questions afterwards. I will give you their bios to start off with, and then we'll get things rolling. Bibiana McHugh is the manager of mobility and location-based services at TriMet Portland, which is a transit system in Portland, Oregon. Bibiana has led several innovative technology and data initiatives in the agency over the last 20 years. She initiated the collaboration with Google for the first release of Google Transit, initiated development of the OpenTripPlanner, OTP, open source multimodal trip planner, and implemented an open GIS platform at TriMet. Most recently, she led a team of partners on the 2017-19 FTA Mobility on Demand Sandbox grant project, and to extend OTP to include private mobility service providers. Aaron is the founding principal of Trillium Solutions, Inc., and the technical co-director of the Rocky Mountain Institute's Mobility Data Program. Aaron's 10-year career in transportation covers technology, data, design, and planning work with all modes. He currently focuses on helping public transportation serve its crucial purposes and thrive in the mobility as a service paradigm through tactical engagement with transportation providers in their technology stack and global strategy. Bibiana, are you there?
Yes, I'm here.
Okay, and you.
Thank you, Brendan.
Now you want me to advance your slides, is that, or Janneke, are you doing that? Or do you have?
Yeah, you can just hand control over to me if you'd like.
Okay, or Janneke, can you do that?
Okay, can everyone see my screen?
I can. It's not full screen, or is it full screen? Maybe it is.
Okay, I'll assume it's full screen then and move forward.
Go ahead, Bibiana.
Okay, thank you. Thank you so much, Brendan, for this opportunity. And again, I'm Bibiana McHugh from TriMet, and I'm going to show you our next generation trip planner, which is the result of the FTA Mod Sandbox grant. So I'm going to start a little bit with how this all started. with the biggest disruption in the transit industry that we've ever seen, and that's with the introduction of private mobility service providers. Private mobility service providers meaning any provider that provides transportation between A and B that is not public transportation, such as TNCs, car share, ride share, bike share. And I love this slide. I asked for permission to use this slide from the transit center. But again, I think this really demonstrates the issue and the problem that is going on throughout the world. The buses and bicycles take a lot less space on our roads than cars do. However, buses and bikes can't get door-to-door service. And that's kind of what our customers are expecting now. With the introduction of Uber and even autonomous vehicles, it's not solving the problem. It's making it worse. We've got more and more cars on the road. I just heard a statistic recently that there are 2,300 people moving to Portland every month. And I'd hate to think that there are 2,300 more cars on the road every month. So what transit needs to be doing, and what the FTA has been, encouraging transit agencies to do, is to move from the role of just a public service provider into that of a mobility manager throughout the region. Mobility as a service, providing mobility as a service, providing integration of services, and really looking at it more holistically across the entire industry, across the entire ecosystem, beyond just operating buses and trains. So when I talk about mobility as a service, there's a lot of components to it, but in this aspect, I'm going to speak of a multimodal trip planning, public and private service provider partnerships, an integrated payment plan, and customer information. Customer information requires open data, standards, personalized customer information sharing and services, things of that nature. In order to support this, though, you really, all of the Mod Sandbox awardees, what we're coming to realize is that that isn't enough. In order to provide mobility as a service, you really need a strong mobility management foundation underneath that. That foundation would support technology and innovation, policies and regulations for data, for on-street right-of-way and access, incentives and influence, not just for third-party providers, but also for our travelers, facilities, land use, just the management and integration of the modes, and then also, most importantly, equity and accessibility. That's one of the things that really kind of separates us from the private service providers, and that is the responsibility to provide an equitable and accessible transportation system. So the Mod Sandbox grant, TriMet was awarded. We were one of 11 transit agencies awarded the grant. We were awarded $678,000, and with in-kind contributions, it exceeded $1 million. It ran from January 20th, 2017, and ends this coming January 2019. And there's more information about our project at trimet.org/mod. We've got all kinds of information, including more detailed information about all the key components of our Mod Sandbox grant. Kind of a dashboard that has shown our progress over the last couple of years. and how we've gotten to where we are today. So our solution was basically to take existing software and data platforms to integrate shared use modes with public transportation. And our strategy was to leverage open source, open data, and open standards to facilitate wide adoption. We really wanted to create something that was not just for Portland, Oregon, but that was replicable worldwide. We started with OpenTripPlanner. OpenTripPlanner was initially developed back in 2009 with a small grant. It's now worldwide. It was initially created to, initially it was just biking and transit and walking. And with this project, we extended it out to include any and all private mobility service providers to integrate that in with transit. We used all open data. OpenTripPlanner runs on OpenStreetMap, and a big part of this project was adding in data, more rich information into OpenStreetMap, such as sidewalks, crosswalks, speed limits, things like that. It uses all open data, open standards, including GTFS, and Aaron will talk more about GTFS and GTFS flexes and other standards that facilitate transportation trip planning. And last but not least, I also want to mention our Peleus geocoder. The Peleus geocoder was initially started by Matt Zen, and it was an open source product. And we wanted to take Peleus to this next level. Again, a geocoder is a main functional requirement of a trip planner, and it locates an address on a map. And there was really, I don't believe there's any open source geocoders out there. A lot of people use the Google API. However, recently it's become cost prohibitive for a lot due to the recent price hike. So Peleus is really a great alternative right now. It uses a full planet search. It's similar to OpenStreetMap, where it is worldwide and seamless. It's non-proprietary, and it pulls information from a variety of open data sources. We've been doing benchmark tests over the past couple of years, and we're very, extremely pleased with the way that the Peleus geocoder is performing, especially in relationship with other trip planners, and especially when looking at it from a transit trip planning perspective, because we have more control over it and we're able to put in transit specific data, such as park and rides, stop IDs, things of that nature. The fourth kind of part or task of this project was the integrated payment plan. And we worked with Movil to facilitate compatibility with planned book and payment features. They are developing a plan that will be included in our final report for integrated payment. In the future, this application, the next evolution, the next phase is to create a complete plan, book, and pay application. I want to say here that probably one of the most difficult parts of this project was the data aspects, access to open APIs from service providers. And they're not all in a standardized format either. So OpenTripPlanner, and not just for OpenTripPlanner, but really any application out there, in order to facilitate intermodal trip planning, you really need access to the APIs that is unrestricted. licensing use. So with that, I'm going to show you a little bit about the trip planner. I'm not going to do a live demo, but these are screenshots. And this is actually the first time I used the trip planner. I was at the airport and I needed to get across town, and to get from the airport to St. John's, it would have taken me close to an hour and a half. I then planned the trip using Uber plus transit instead of just transit. And basically, it kept my time down significantly. And what it had me doing was taking the Uber to the first stop on the line 75. This isn't intuitive to a lot of people. And what this really demonstrates is really the importance of the integration of multi-modes within a trip planner. This can significantly save time and cost, which is especially important for low-income groups. Now, without integrated booking, the next best thing, what we're doing is we're deep linking. So if you book a ride for the Uber, it takes you over to the Uber app and automatically keys in the origin and destination. Taking the trip from the airport to the first stop on the 75, it's about $15. If you take it all the way from the origin to the destination, it's $28. So you're saving about $13 in fees. Another thing that it does is it provides driving directions to park and ride locations. This is the only time too where the OpenTripPlanner really plans driving directions. All transit itineraries that are returned include a transit component. So you're not going to see just driving or just Uber or just Car2Go. Everything is integrated in with a transit leg to encourage transit multi-use integration. We have Car2Go integrated in here, Bike Town, and if you own your own bikes, Bike Town, we're pulling directly from the API, and we've the symbol here actually represents the number of available docks and the number of available bikes. It also shows floating bikes. Again, the only way we're able to really show this is through the real-time API where we're getting the information. We're also using the elevation, national elevation data set, and detailed information that we've inputted into OpenStreetMap to make improvements. So you're also able to plan your trips based on bike-friendly or safest, those with fewest transfers, the flattest trips, or speed. We also have zip car locations and real-time service updates. So if there's a service disruption, it will automatically alert the user and provide adjusted itineraries based on the service delays. So next steps for this, we're currently beta testing it. We have 250 participants who are testing it and performing a survey run by FTA and Berkeley. We also have extensive internal and external partner testing, followed with a questionnaire. We're doing in-field shadowing and a second heuristic usability study. The analysis and the results and the reassessment will help us redefine and give a more accurate scope and release date for the first quarter of 2019. And I'd like to mention just a couple things. We have been working closely with other OTP developments and agencies and companies worldwide on incorporating features such as ours into theirs and vice versa. And we've had just an amazing group of partners that have contributed immensely on this project over the last couple of years. So with that, I want to thank you and hand it back over to Brendan.
Thank you very much, Bibiana. That's as I thought it would be, very, very interesting, and I learned a whole bunch of new things. Let's pass it on to Aaron, and we'll have his presentation, and then if you can hold your questions, and there's the chat box. You can start putting questions in as we go along. So, Aaron, I think Jannika's giving you control. Are you there, Aaron?
I am. Can everyone hear my voice and see a slide deck that says mobility data at the top?
Yes, and
yes.
I can hear.
Okay. That is great. Okay, hold on. GoToWebinar wants me to change one setting, so I'm changing that setting right now. Great. All right.
All good.
Terrific. So my name is Aaron Antrim, and I have founded a firm that uses standardized data to make transit easier to use. I'm also co-director of a project called Mobility Data that started by Rocky Mountain Institute. And the interest here is to develop a shared data language for transportation. And we believe that is fundamental to realizing mobility as a service. And Bibiana has already laid this, given this super compelling example of how that works and why that's important. And what I'd like to do is go back to some of the fundamental, our fundamental thinking about mobility as a service and standardized transportation. Mobility as a service and standardized data. So one of the things we hear, mobility as a service has become this buzzword du jour. And we hear seamless, seamless, seamless. And I was at a presentation where a fellow from Transport for London said, we hear a lot about seamlessness, but actually a well-made suit has seams. It's just you can't see them. They've been very finely crafted, and I think that's important to remember. Our transportation system and our information systems for transportation are going to have a lot of parts that we need to fit together. And so one of the mobility data beliefs is that we use interoperable data and systems to bring these separate components, these different service providers together into a system where the seams are less visible. And here's this image is meant to show an architecture where there's a lot of one-off connections between different applications and different systems. Right? We have a scheduling system and a real-time system and a trip planner all talking to each other with idiosyncratic languages, and adapters need to be written to get all these systems to talk to each other. And this sort of architecture is expensive to build and to maintain, and it's brittle. If you want to make any changes, if you want to remodel some part of your system, there's a whole lot of, you have to write new adapters to get these different systems talking to each other. And so by having shared language like GTFS, like other standardized interfaces, it's possible to both have a system that's more seamless and that's easier to maintain, that will allow us to incorporate new software, new apps, and other systems we need to serve travelers. And so back to these, I'm just really belaboring the sort of fundamental motivating principles here. Let's think about a world without interoperable data and interfaces for a second. Without HTML and JavaScript and XML, we don't have a choice of web browsers. We can't see the same page in both Firefox and Safari. I can't send you email if you're using Outlook and I'm using Gmail. And transit apps, of course, that consume GTFS and GTFS real-time and other formats don't exist. And even our whole banking system and mobile phones don't work. So interoperability and standardized interfaces and data are super important. And the goal of mobility data, one of the goals of TriMet's Mod 10 grant, and another project I'll talk about in Vermont is to create this shared language of data standards. Because to realize mobility as a service, we need complete data streams for our share, for bike share, for other modes, just like Bibiana talked about in the previous presentation. And those complete data streams are key to making the multimodal transportation network truly greater than the sum of its parts, so that you're able to stitch together trips like Bibiana showed, where you cut travel time in half by combining a TNC and transit option in an efficient way and significantly reduce costs. So there are several barriers to representing the transportation network completely and bringing all of its pieces together. One of those barriers is policy. One barrier is technical, and the lack of standardized formats for some modes, or the slowness of adoption for some of those formats. And so I'd like to take a moment to look at the standardized formats that we have available for various modes. For fixed route transit, there's of course GTFS and its companion extension GTFS real-time for service advisories, vehicle positions, and arrival estimates. For demand responsive transit, ride-hailing, taxis, and paratransit, there's a number of vendor-specific APIs like the Lyft and Uber APIs. There is also an emerging GTFS Flex extension that I'll talk about in a second. And there's a format coming out of a TCRP G16 project for facilitating transactions in demand responsive transportation. For the pedestrian network and bike share, or rather for the pedestrian network and bikeways, we have OpenTripPlanner. And for bike share, there is the general bike share feed specification for both docked and dockless bikes. For carpool and vanpool, we really haven't seen, we've seen several attempts to standardize data and interfaces for that mode, but none have succeeded. So I just put a question mark there. And for payment systems, we depend, of course, on the banking system, which can be expensive. There's also vendor and agency-specific APIs and software development kits. And TriMet's HOP provides a really compelling example of a payment system that can be integrated with other systems. So let's turn to talking about where mobility data fits in here. Mobility data grew out of work that Trillium had been doing for years, work that other stakeholders had been doing, like TriMet, and work that Rocky Mountain Institute was doing, and they're thinking about mobility as a service. We knew that standardization was very important, and we asked, well, where do we begin to help make that happen? And we landed on, let's work with GTFS data and improve, or the GTFS format, and help it do more and go farther. So the goals are to broaden adoption of standardized formats so mobility data is available throughout the world, to increase the completeness of those data formats so that more transit service features can be represented in apps, and to enhance accuracy and quality of data to ensure that the information travelers see in an app matches the real world. So let's talk about what that means. Looking at the present governance model for GTFS, we have producing applications, producing GTFS, this shared language for transit, and then consuming applications. And there's a variety of different types of consuming applications using that data: trip planners, mobile apps, timetables, and then internal applications for performance measurement and network analysis. And the process of governing GTFS is really a dialogue between producing and consuming applications, understanding what are the use cases of consuming applications that then drive data requirements and drive that shared language, that shared GTFS language, and the data that's coming from producing applications. So what we're doing to facilitate that process is to make GTFS more clear, to add features to GTFS, and to make research easier to access. So the features that we're working to add to GTFS will describe more transit services and aspects of those transit services. One is demand responsive transit, that is deviated fixed route, flag stop, point deviation, and dial-a-ride service. Another is service changes, such as temporary detours. And this is really important. Right now, GTFS doesn't have a full ability to describe temporary service changes. And so customers may get information about that through a service advisory, but a trip planner is not able to fully represent the detour that's active. And so this is really important to be able to reliably serve customers. We're adding vehicle and station features for step-free accessible transit. So this includes elevators in stations and the real-time status of those elevators, which is absolutely crucial if you are using a wheelchair or, say, a stroller, because that's going to significantly impact the way you use the transit system and your access to transit. Expanding GTFS's capabilities with regard to fare structures and travel restrictions, and allowing lines and service and operator names, that is transit branding, to be expressed throughout the world, because there's a variety of ways in which transit services are presented to customers. So the process to add these features involves first gathering data producers and consumers, and hopefully there are people on this call and organizations represented on this call that are interested in being part of this process. Establishing the use cases, developing specifications around those use cases, and then observing practice and experimenting. And this follows how GTFS was first created. So we already saw one example where software and use cases and data specifications have all been, worked on together in this similar order and process. That is TriMet's OpenTripPlanner and OpenTripPlanner Shared Use Mobility Project. And another example is one that Trillium has led in Vermont, and that is to add other demand responsive modes to OpenTripPlanner. Because demand responsive transit doesn't currently exist in Google Maps. That is, a deviated fixed route service will not show up in Google Maps. And for a lot of customers, that's equivalent to it not really existing, because if you can't discover it in Google Maps, at least I'll speak for myself, if I can't discover something in Google Maps, that's a major barrier to me being able to discover it at all and use that service. And so if I have time, I can show some more itineraries, but I'll just start with this screenshot of the same trip where we're going from St. Johnsbury to Montpelier. And the trip planner is showing that there is a dial-a-ride, a zone-based dial-a-ride service available, and instructing the user to call rural community transportation, giving notes about how that service needs to be used, and then identifying that this is an intermodal trip, and the customer would then travel on a fixed route service to Montpelier. So long term, I'll say back to the this notion of software and data standards together. GTFS Flex and OpenTripPlanner for Vermont, those two initiatives are happening in tandem, and we were able to prove that GTFS Flex works and is useful. This is this extension to GTFS for demand responsive transportation, and that it works and is useful. And there's significant interest from a lot of other firms, including big, popular online maps, in incorporating this data in their products. So pursuing standardized data and real examples in a working application, we believe is a model that should be replicated, and it's working. So this is, I've talked a lot about the theoreticals of developing data standards, and I'd like to return to what are real practical things that transit agencies can do right now in order to engage with this world and take advantage of opportunities that are available. The first is to just leverage existing standards by requiring them in procurement documents. And so there's GTFS at gtfs.org. There's GTFS Real-Time 2.0, which is a data specification that involves detailed requirements from data specification that has more detailed requirements from the University of South Florida. There's GTFS Flex. And also we recommend looking at the GTFS best practices, which were agreed to by 17 organizations last year, and provide clarity where the core reference does not. And then we recommend that transit agencies get involved in the standards processes in order to fill in the gaps of that are missing in the present specifications. So I'm imagining that we have time for questions in this webinar, and we can get to those. I'm just going to put up contact information for mobility data if you would like to get involved in any of the working groups for branding, service changes, demand responsive transit, or fares. Brendan, are you still there? And do we have time for questions now?
I am, Aaron. Thank you very much. Yes, it was quite interesting. We do have time for questions. Please put them in the chat. There's one question about the availability of these presentations. We haven't quite discussed that, but if you're both willing, we can post them on the ITS Canada website, I believe. Yannicka, right? I think
yes,
Yannicka.
we can. Yeah,
Yes.
sorry, I had it on mute, but I'm also recording this webinar, so I have to see what the format is that comes out of it, but after permission from Bibiana and Aaron, we can also share that particular link.
Okay. So I'm waiting to see questions, but I have one. Maybe I'll start off with a question for Bibiana. And if you're off your mute, how you mentioned that the data sharing and the use of APIs is one of the challenging points, and this is well known and very complex. I know that several of the MOD sandbox projects were delayed because of this issue of sharing data. And from what I can see of the way your example there, it looks like competing modes, such as Uber and Lyft, would at least be able to see each other's availability and so forth. Has this been how's the adoption been? Have people bought in, and can you talk a little bit about that?
Yes, we worked with both Uber and Lyft, and I'm very, very happy and proud to say that it was released in beta with both Uber and Lyft in the beta test application. That's quite a feat, and it was challenging, but I think working directly with both of them, I think a lot of lessons were learned on all sides. One of the perspectives I gained was that, again, although both have APIs to their data, there's limitations and license use restrictions on how to use them. You can't use the data and information in an application where competitors exist. And one of the main reasons for that is ETA, estimated time of arrivals. And estimated time of arrivals aren't always that accurate. And I think if you can imagine someone selecting a trip based on closest arrival time by a private service provider, that may have an effect. What I think we're trying to demonstrate with this app, and what the app is demonstrating, is people are looking at the total trip time. And the total trip time, the ETA is only a part of that, especially when you're looking at, like 15-minute headways. So, there are also a lot more multimodal trip planners that you're going to be seeing out there, and a lot more apps that integrate them all. Ours, I think, besides Google, is probably the first legal one. But, there's not a lot of control over the apps that are being developed anyway. So again, I think it's been a really great learning experience for all of us, and we've come a long way over the last 2.5 years, and I think it's a really amazing app that demonstrates the importance of partnerships and open data.
Yes, that's great. I think it is a great step forward. I think there will be a lot of experimentation and challenges because I can see the connection, sort of guaranteeing transfer times is going to be sometimes a challenge. Question for Aaron. Could you elaborate a little bit more on, I don't think the audience is really aware of the GTFS best practices document. Could you elaborate a little bit more about what's in it and why it's needed?
Sure. How about can I share can I share my screen again?
I think you've got it there. Yeah.
Okay. Let's see. Great. The first thing I wanted to share is that everyone should see the transit blog, right?
Yes, the Monopoly sort of board.
The mobility
Yes.
board.
Yeah.
This is to Bibiana's earlier point about the usage restrictions that exist with APIs. This is a great blog post from the Transit app about the sorts of limited access to data we see from some mobility providers in an attempt to control the marketplace. So an interesting discussion, and they offer some practical advice for things that cities and regional governments can do to ensure more open data and a more open marketplace. So to this question about the GTFS best practices, I'm just going to dive into a few examples of the best practices. The best practices aimed to provide clarity where the GTFS core reference was silent. So in some cases, it was unclear how to represent a loop route. A loop route should be represented by consecutive trips that share block IDs and that have both the first and the same stop represented as the first and the last stop. And so the best practices describe how to represent a loop route correctly in GTFS. They also describe how to describe. They also prescribe how to represent a lasso route, like the loop in Chicago, and also they define how to describe branches with head signs and with the trips and routes, so that agencies can get predictable outcomes in third-party applications. Google, the Transit app, Conveil, TriMet, these were all organizations involved in defining these best practices. And so they represent a consensus view of they represent a consensus view of a shared language for transit data. Let's take a look at some of the other items in best practices. There's prescriptions about how to define stop names, and then also how to define parent stations and child stops. And I could pull up a slide deck and show a few examples of how data that doesn't conform to these best practices yields poor results in trip planners and other applications, but I don't want to
Yeah.
delay
No,
building up
I
to
think we
the
get the. Thanks, Aaron. I think we get the idea. We should.
and you
We'll
know,
share this with our
yeah,
committee.
I just want to comment a little bit on the motivation, and um, without this clarity, it was really difficult to impossible for transit agencies to require good quality GTFS from a vendor, because good quality GTFS wasn't clearly defined. So our goal is to make it that much more clearly defined, so that the best practices can be dropped into a contract, dropped into a procurement document, and the transit agency can much more easily guarantee good outcomes for their customers.
That's an excellent point. Question for Bibiana. I know this is still just a beta test, a pilot project. Have you had any interactions with Google itself to see if they have any interest in adopting any of the developments that you've piloted here? I think you're on mute.
Sorry. Well, Google Transit uses their own proprietary, software and routing algorithm. It's not true multimodal. Google will plan, transit or bike or walk, but not an integration of them. Although they do also include, though, Uber and Lyft. However, again, they don't produce integrated itineraries. They're using their own, algorithm. And, they may be moving towards that. They probably will. I think the more applications out there that facilitate seamlessness in movement between modes is great, is good. Anything that we can do to help shape behavioral changes and, again, the seamlessness of the mobility, I think is good. So it's not there now, but it may be in the future on Google.
Yeah, no, that's great. Actually, I've got another question for you, Bibiana. I was curious about the in-field shadowing. Could you just elaborate what did that mean, or how did that happen?
Well, we wanted to get more detailed information outside of just online surveys and questionnaires. And because of our e-survey, or electronic survey program, we have a lot of resources, internal resources. We have quite a few college students that are equipped with training, customer service knowledge, as well as tablets. So we're pairing them up with travelers that may have unique disabilities. For instance, using the Wave call to the Uber API to call for a specific trip requiring a wheelchair. So we just wanted to get more one-on-one information about how people are really using it, and if there are any, and what any, barriers that might exist, out in the field. So that's what we're doing with the infield. It's not as formal as the online survey, but the idea is to capture more qualitative information from our users.
Yes, thanks. Actually, another question, but it's more Bibiana, but I guess both of you. There's always the issue of user privacy, and when you put into open platforms multiple mobility providers, is there any concern expressed by either the providers, or how do you address that sort of issue going forward?
The issue going forward of I'm sorry.
Of protecting privacy of individuals. Is there any concern that people could actually be tracked more individual basis if they use the application with multiple providers?
I think that comes up when you're talking about integrating fare payment, because in those cases, you necessarily have a user token, some sort of way of, an account, a fare card, a credit card, some way of tying behavior back to a specific individual, even if you don't know who that individual is. But with trip planning, there perhaps are some theoretical privacy concerns which are easily managed if an organization is retaining trip plan A to B pairs. But I think these issues really come up when you enter into integrating fare payment. Bibiana, do you have any thoughts?
That's exactly right. Other than that, you're really just using a trip planner. You're not logging in or signing on, anything like that. And that is kind of the one advantage too of using just the data, just the open data APIs that the service providers have, as opposed to requesting additional information from them. Then it's not subject to FOIA requests because it's already out there. Anybody could get it, and we're not having to deal with those privacy concerns.
Yeah, thank you. That's correct. The question was sort of in reference, and I guess it's more to the future of a full-blown mobility as a service application. And I think you're right there. And it's when you start looking at identifying individuals because of payment processes, and then there may be greater concerns.
And I think we can, Bibiana, it may make sense to point out that that's been, that TriMet has been very careful about protecting anonymity with the HOP FastPass program, and that there's ways of managing those. There's ways of managing those privacy questions.
Exactly.
Okay, I think we're coming up to the hour, and I don't have any additional questions that I can see. I want to thank you both for the presentations. I think Aaron mentioned an open invitation to anybody who wants to participate in refining and improving, making more robust these specifications to participate, and contact him, and his email address is on the line. And I'll just also reiterate that if anybody's interested in participating in the APTS committee, to just drop me a line and I'll add them to the distribution list. And I think with that, I would like to thank you both for participating. Thank everybody who was on the webinar for this busy holiday time, and wish everybody the best and happy holidays for the coming weeks. Thank you very much. Yannicka?
And thank you.
Thank you.
Thank you, Brendan, for organizing this webinar.
Happy holidays to everybody.
Happy holidays.
Thank you all. Thanks for the good question. Bye.